On January 2, 2025, the Ministry of Defense of Ukraine held a demonstration of first-person view (FPV) drones controlled via fiber optic cables. This presentation, organized by the Maine Department of Defense Innovations, aimed to showcase advancements as part of a program to introduce new technologies for the development of the Army of the future. Representatives from the Armed Forces of Ukraine's various branches attended the event to observe the performance and potential applications of these systems. The demonstration included over a dozen FPV drone models produced by domestic manufacturers. These drones, some capable of carrying payloads of up to 3 kilograms, were tested in front of experienced UAV operators who evaluated their tactical and technical characteristics. According to Lieutenant Colonel Yevgeny Tkachenko, head of the Unmanned Aviation Systems Department, these drones are intended to address advancements in enemy drone control capabilities using fiber optics. He stated that several models presented are in the final stages of codification and will soon be delivered to the Armed Forces of Ukraine. Fiber optic control systems provide a physical link between the operator and the drone, making these drones resistant to electronic warfare (EW) measures such as radio frequency jamming. Senior Soldier Iru, an operator from the Armed Forces of Ukraine, noted that the technology offers operational advantages under specific conditions despite limitations inherent to the use of fiber optic cables. These drones are currently used by the 414th Separate Regiment of Strike Unmanned Aerial Systems, known as the Birds of Magyar, which employs designs developed by the regiment's Climate Team Engineering Unit. Russia has implemented various electronic warfare (EW) strategies to counter Ukrainian first-person view (FPV) drones. These measures include deploying portable EW devices in trenches and dugouts to disrupt drone communications, equipping reconnaissance drones with rear-view cameras and automated evasion systems to detect and avoid Ukrainian FPV interceptors, and developing specialized drones, such as flamethrower-equipped FPV models, designed to neutralize Ukrainian UAVs. The emphasis on countering these small drones stems from their significant impact on the battlefield. Ukrainian FPV drones, often cost-effective and repurposed from civilian models, have been instrumental in disrupting Russian reconnaissance efforts and targeting larger Russian UAVs. Their agility and effectiveness pose a substantial threat to Russian military operations, prompting Russia to invest considerable resources in developing countermeasures to mitigate the tactical advantages these drones provide to Ukrainian forces. Fiber optic-controlled FPV drones could represent a significant evolution, as they are designed to retain their effectiveness in electronic warfare (EW) environments. Traditional drones, reliant on radio frequency (RF) signals, are susceptible to jamming and interception, limiting their operational effectiveness in contested zones like Ukraine. Fiber optic systems provide a secure, unjammable communication link via a cable connecting the drone to its operator, ensuring reliability and precision even under intensive EW interference. These drones offer several advantages. Their immunity to RF jamming ensures uninterrupted control and secure data transmission, while the use of fiber optic cables supports high bandwidth, low latency video feeds for real-time targeting and decision-making. Additionally, the lack of RF emissions makes these drones less detectable, enhancing stealth during missions. However, they also have limitations, including reduced maneuverability due to the trailing cable, range constraints defined by cable length, and increased vulnerability to physical damage of the cable in hostile or cluttered environments. Deployment of these systems has been observed on both sides of the Ukraine conflict. Russia has deployed drones such as the Prince Vandal of Novgorod, produced by NPC Ushqui. This drone uses fiber optic cables to maintain a stable communication link and is reportedly resistant to standard EW countermeasures. The Vandal has been used in military operations, targeting Ukrainian armored vehicles and reconnaissance missions. However, the drone's origins have been questioned, with Ukrainian specialist Serhiy Beskresnov suggesting it may be an adaptation of the Chinese-made Skywalker drone. Reports indicate that Russia imports these drones for approximately $2,000 each, repurposing them for military use at a higher cost. The Vandal's design includes features to support the weight of fiber optic spools, which can range from 1.1 kilograms for 5 kilometers to 2.3 kilograms for 10 kilometers of cable. The cable restricts maneuverability and increases vulnerability to physical damage. Ukrainian forces captured one Vandal drone during combat in eastern Ukraine, which provided insights into its operational framework, including the use of fiber optic control systems to avoid detection by radio-based EW countermeasures. China has also demonstrated the development of fiber optic controlled drones. These drones are equipped with reels of varying lengths to adapt to mission requirements, reflecting a growing global interest in this technology. Reports from August 2024 documented the deployment of Chinese drones with similar capabilities. While these systems offer advantages in avoiding electronic interference, they also face limitations such as reduced maneuverability, payload capacity, and operational range tied to the length of the cable. Therefore, fiber optic drones are set to play an increasingly significant role in the Ukraine conflict, as Ukrainian forces have also tested similar systems, such as the Bandar-Strichka. Their design enables reliable communication in electronic warfare environments, with unjammable data links and improved targeting accuracy for infantry and lighter targets. However, their use is constrained by limited maneuverability due to the fiber optic cable, vulnerability to physical barriers, and a restricted operational range. While these drones have proven effective for certain tactical applications, such as targeting vehicles and monitoring positions, their limitations and the development of countermeasures indicate that they are a specialized tool rather than a universal solution in modern warfare. Thanks for watching.